How does Python handle function overloading?
In contrast to statically typed languages like Java or C++, Python does not support traditional function overloading in the sense of defining multiple functions with the same name but different sets of parameters. In those languages, the compiler distinguishes between different versions of a function based on the number and types of arguments. Python, being dynamically typed and interpreted, does not differentiate between functions based on their signature alone. When a function is defined in Python, any new definition with the same name will overwrite the previous one, regardless of the number types of parameters. This absence of native function overloading means that developers must rely on alternative techniques to achieve similar behavior. One common approach is to use default arguments in the function definition. By assigning default values to parameters, a single function can be called with a varying number of arguments, allowing for optional inputs. This enables flexibility in function invocation while maintaining a single implementation. For example, a function may have parameters with default values such that it can be called with 1, 2, or 3 arguments, and the internal logic can adapt accordingly. Another method to mimic overloading is through the use of variable length argument lists using args and kwargs. These constructs allow a function to accept any number of positional and keyword arguments. Inside the function, conditional logic can be used to inspect the number, types, or names of the provided arguments and branch accordingly. This allows for a form of dynamic behavior that resembles overloading, though it requires more manual inspection and design discipline. Type checking within the function body is another tool that developers can use to approximate function overloading. The function can examine the types of its inputs using constructs like instance or type, and then execute different blocks of code depending on the type of the arguments received. While this approach is functional, it can lead to verbose and less elegant code, especially when there are many variations to support. It also goes against the spirit of duck typing in Python, which favors behavior over explicit type checking. For those who require stricter function overloading features, Python's functools module offers a decorator called single dispatch, which enables a kind of single argument function overloading based on the type of the first argument. With @SingleDispatch, a generic function is defined, and specific versions can be registered for different types. When the function is called, the correct version is chosen at runtime based on the type of the first argument. This provides a structured and extensible way to achieve type-based polymorphism without violating Python's dynamic nature. In conclusion, Python does not support classical function overloading by name and signature. Instead, it relies on mechanisms such as default arguments, variable length arguments, type checking within the function body, and tools like single dispatch for more advanced scenarios. While this requires more effort from the developer compared to languages with built-in overloading, it aligns with Python's design philosophy of simplicity and explicitness. The flexibility provided by these mechanisms allows for rich, adaptable function behavior within a single, unified definition.